Let me start the proof. For the proof, first we need to give the basic equation of Fourier transform. So the basic equation of Fourier transform is Fourier of f of x equals to integral of e to the iota sx times f of x dx. Remember, this is the basic equation for the Fourier transform. It is just the different notation for the Fourier transform. Whether you use f of s or Fourier of f of x, it is one thing. Fourier transform of f of x or f of s, it is absolutely one thing. Now to substitute the value for the f of x. The value of f of x was Fourier of x sub 1 convolved with x sub 2 equals to integral of e to the iota st into integral of x sub 1 of u times x sub 2 of t minus u. Because look, this thing equals to f of x. F of x on the left side and f of x on the right side. So just plug in this thing for f of x. On the left side you have to put x sub 1 convolved with x sub 2 for f of x. On the right side you have to plug in all these things. Look here, I have iota isx. I just replace x by t. If your independent variable is x like dx, you have to put x here. If your independent variable is t like dt, you have to plug in t here. So since I took dt, therefore I'm going to put t here, not x. For the rest, for the f of x, I plug in x sub 1 convolved with x sub 2. Here for the f of x, I plug in the right side. This whole thing. Just plug in this integration for f of x. Now to take out this integration here, just take out this integration here and put it there with the first integration. So I will have double integral of e to the iota st times x sub 1 of u times x sub 2 of t minus u times du dt. To further simplification, to have integral of x sub 1 of u into integral of e to the iota s of u plus x times x sub 2 of x dx du. What I did, I just took x sub 1 of u and put it there with the first integration here. But what about t? Where this u plus x came for the t and x for the t minus u, what happened? Just plug in t minus u equals to x, which implies that dt equals to dx. Replace this t minus u equals to x, and then when you take derivative on both sides, you will get dt equals to dx. Since our independent variable is t here, so I'm going to ignore the u, I'm going to pick the t term. It is a partial derivative. So derivative of t is dt and derivative of x is dx. Now what about t? For the t I have to put u plus x, because look, t equals to u plus x. You have to bring this negative u to the right side to become positive u. So t equals to x plus u or u plus x. Therefore I plugged in t equals to u plus x and t minus u equals to x, because t minus u equals to x. dt equals to dx. Just replace this dt by dx and put this du as it is. You know that I have taken x sub 1 of u out and put it there with the first integration. The further simplification, to have e to the iota su times e to the iota sx. Look, take the product of iota s with u plus x. The product of iota s and u will be iota su, and the product of iota sx will be iota sx. So I will have iota su plus iota sx. Now can I write iota su plus iota sx in the product form? Yes. I can write it in this form, e to the iota su times e to the iota sx. Because after simplification you will get back the same thing. You will get the exact same thing when you simplify it further, because both the terms have same basis, base e and base e. So their powers will be added. After adding their powers, you have to take out iota s common. There you go, you will get back the same thing. Just do some modifications, write this term in such shape. Now to separate the term, can I put e to the iota su with x sub 1 of u? Yes, because my independent variable is u here, so I'm gonna choose this term with a u. And I have to put e to the iota sx with this x sub 2 of x, because its independent variable is x. So separate the terms with a u and terms with the x. I'm gonna bring this e to the iota su with x sub 1 of u and this du here as well. And x sub 2 of x times e to the iota x times dx on one side. Therefore, my new expression will be integral of x sub 1 of u times e to the iota su into integral of e to the iota sx times x sub 2 of x times dx du. I just separated the terms with the u variable on one side and terms with the x variables on another side. But still I need to pull up this du with this integration. So I will have integral of e to the iota su times x sub 1 of u times du into integral of e to the iota sx times x sub 2 of x times dx. Now I have a complete separations of the integrations. All the terms with the u variables on one side and all the terms with the x variables on another side. Replace all the u by t and all the x by t. Suppose I want to replace all the u by t and all the x by t. Just let u equals to t and x equals to t. So I will have integral of e to the iota st times x sub 1 of t times dt into integral of e to the iota st times x sub 2 of t dt. Just suppose u equals to t and x equals to t. Why I do this? I do this just to make both integration similar, to have the same independent variable which is t. Now can I write integration of e to the iota st times x sub 1 of t dt equals to Fourier transform of x sub 1 of t? Yes. What is this? What is this? It is nothing but the formula for the Fourier transform. It is the formula for the Fourier transform. It is like the Fourier transform of x sub 1 of t. What is my function? My function is x sub 1 of t. This is my function. So instead of f of x, I'm going to put Fourier of x sub 1 of t. So this is the formula for the Fourier transform. Remember, this notation is the Fourier transform. So Fourier transform of x sub 1 of t times, what about this? It is nothing but the Fourier transform of x sub 2 of t. So what is my function? My function is x sub 2. For f of x, I'm going to put x sub 2 of t. So the Fourier transform of x sub 2 of t. It is the Fourier transform of x sub 1 of t times it is the Fourier transform of x sub 2 of t. Hence, the theorem has been proved. That's what we would needed to prove, that the left side equals to the right side. So we got it that this left side equals to the right side. So that was my task, that this left side equals to the right side. So there we have proved the convolution theorem in such way.